Good morning, everyone. I'm Chaitra. Today I'll be okay. I'm Chaitra. I'll be taking your Fundamentals of Business Mathematics and Statistics paper. So, before that, I would like to introduce myself. I'm Chaitra and I have done my Bachelor of Engineering in Computer Science and Engineering and MTech in Computer Science and Engineering, and presently pursuing PhD in Computer Science and Engineering. So, today in our class, I'll go through our syllabus. Okay. So, what are the contents, what are the modules we have, so on. So, you can see on the screen. So this is two sections, section A and section B. In section A, fundamentals of business mathematics will be one part and the statistics part will be in the section B. So in section A, three modules, that is arithmetic, algebra and calculus. And calculus basically they do with respect to application in business. So next in section B, we have a statistical representation of data. So we need this, how to represent the data in statistically, visually, and so on. So your exams will be in MCQ pattern. So we need not go more detail like how to prove it and so on. So we will have 4 options and question will be given. You should find the shortest way to find that answer. So basically you need to know the concept, okay, concept and what are the shortcuts we have to find a solution. Sometimes you need not go through a longer step to find the solution. Just from the options you can find the correct answers by relating it to the questions. So as I told you before, please concentrate more on concepts. Okay, so let's go through the section B, statistical representation of data. You need not write any representation, you just have to choose which is the right answer for the given representation, so on. Then we have measures of central tendency and dispersion. So what is this related? Correlation and regression, probability, index numbers and time series. Here we will go each one of them little more detail, okay, and then whenever the modules we come across, we'll solve the problems. So today here 40% will be section A and around 60% will be section B, means the weightage. Okay, so you can see on the screen in section A we will be covering around about ratios, variations and proportions, time value of in ratio, variations and proportions. It will be like is to be given some quantity with some ratios, how do you find out, and if you how do you find the actual quantity of it, a given actual quantity, and you subtract with some data, and how do you get the ratio between them changed, also on. Then time value for money and energy. Here we talk more about simple and compound interest. Okay, then arithmetic progression and geometric progression, given some set of numbers. Okay, you should be able to in arithmetic and progression, okay, given this. So you'll be talking about a series of numbers. You want to find the pattern at the end, what is a pattern, so on. And time and distance, it's given time, what is the distance we followed, and you might have traveled some distance, and what is the time, not only with respect to travel but also some particular tasks and so on. So in arithmetic basically you have ratios and simple interests and progressions and time and distance. Okay, these are all completely independent. Okay, and it will help you to go through the concepts. When I come across each topic, you will understand the concept and solve the problems. Next we have algebra. In the algebra part we will be talking about set theory. Okay, so basics, the concepts of set theory, which is necessary for you to answer few questions in MCQs, and Venn diagram related, how given a Venn diagram find out the set, and they have given a Venn diagram where there are few data given and you have to say A union B, B union A, so on. So then we have indices and logarithmics, and when we take this topic, it is actually a huge topic, but in for this exam what you need to know is the basic concepts, okay, like general concepts you need to know. Then permutation and combinations is also a very important one, not only in respect to the your entrance exam, also in real life. You may need to have some probability permutations, like given set of arranged objects or selection of some people and so on. So basic concepts of formulas and all will be useful. Then we have quadratic equation. In quadratic equation, given a equation or a problem, you try to find a quadratic equation and find the unknown terms. However, this is also a basic concepts. So in this three will be basic concepts. The other things we have to go in very detail. Next, we have concepts of calculus and its application in business. Calculus is not only in business but also in scientific field. So basic concept which you may need it for the business purpose will be addressed here. Then we go to revenue and cost functions. Okay, what is the revenue given a cost function? You want to get some profit, so on. So how do you find the cost function given some set of parameters, so on. So then we have optimization techniques. This is very interesting. So you have to reach some particular goal. Okay, there are given set of parameters. Okay, and you have to find the technique which will optimistically reach your goal. Optimistically, now it means whether it is a cost, by time, and so on. So we will go through the basic concepts here. Okay, so I hope you got it in module 1 with ratios, distance, time value, so on. Ratios, variations. Then you will be covering about interest, compound and simple interest. Then progressions, time, distance, and algebra. You will be going through the set theory, indices and logarithms, permutation, combination, quadratic equations. Then in calculus you have the basic concepts of calculus, little bit of cost function and optimization techniques. Clear? Now when we go to the section 2B, okay, from module 4 to remaining modules, okay, you will be having statistical representation of data. Okay, this in section B you have statistical representation of data. In that, diagrammatic representation of data is there. Then frequency distribution. Okay, given data, how you will represent in a statistical way. Then frequency distribution is like you will have different type of data and some data will be frequently repeated, so on. So you will be talking about how frequency is distributed and given. So suppose you have data of some social networking or something, so you want to know how frequently a particular word is used and so on. So that is a real-time example, and you will have the graph representations and you have to tell the frequency distributions. Next we have graphical representations of frequency distribution. Once you understand what is frequency distribution, and you will have histogram, how that is one of the way to represent the frequency of data, where x and y axis will be there. So histogram, frequency polygon. So this is a curve. This curve will also give another way of understanding of data. Okay, then we have ogive and pie charts. So this ogive, maybe this is new for you all. Pie chart, even in school time we might have studied. Okay, we will go through this. There are many representations. This is not limited, but you have many other representations. In that we only cover 1, 2, 3, 4 different statistical representation of data. Okay, so next we have here the module 5. So in module 5, measures of central tendency and dispersions. The overall in this, what all includes is mean, median. Given set of statistical data, you have to find the mean, median, mode, mean deviation. Okay, that also will be statistical, but here, as I said, it is MCQ. So try to find the solution faster. Okay, instead of methods, there are many methods finding and all. So given data, try to find the shortest way to find this mean, median, mode, mean deviation. Then we have range quartiles. Next we have range quartiles and quartile deviations. Okay, so here given the range between the quartiles, you have to find what are the possible solutions for given. The questions can be like find the range, or given a range, find what is the quantity, how much is the quartile, and so on. Next we have standard deviation. So this is also simple one, but not hard. Find the standard deviation for the given data, how the data is deviated. Coefficient variations, suppose I change some parameter, and how will it affect in other parameters, so coefficients of that. Then this is skewness is one of the coefficient, finding the coefficient, that is Carl Pearson and Bowles coefficient skewness. Okay, with this we will have module 5 done. Then we'll come to module 6. In module 6 we have correlation and regression. In this we try to find the relationship between the data, that is using scatter diagram. So scatter diagram, and here we have studied already Pearson's coefficient, here of correlation. Okay, skewness, correlation, a little interrelated to the data. So correlation is a we can find using scatter diagram. Okay, and regression analysis is also related to finding the that is a regression. Also we need to get regression, we need some set of data to correlation and regression, scatter diagram, Carl Pearson coefficient correlation, and regression analysis. In then we have probability concepts and terminologies. Here what is a probability, how do you find? When we take probability alone, there is a huge set of formulas, but we will be going through some few concepts and terminologies used for probability, and here we have primary applications of probability theorems. Next we'll go to module 8, index and time series. In this, how do you find index numbers, where we use what are the methods of construction of index numbers, components of time series, calculation of trend by moving the average method. Here we have, with respect to time, okay, and index, we have to find few values. Okay, that is also simple, given set of data, find the average of it, and so on. But how is it different from the module 5 you will be understanding here. Okay, I hope you understood all the modules. Okay, let me just show you in a brush. So here all this is done. Okay, now let's get into the module 1. Okay, in module 1 you can see here, when you have done this module 1, you will be fine with the ratios, variations, and proportions first thing. So each module will have one session. Let's see how much time it takes. Then time value of money and annuity. Here you have simple and compound interest concept. Then we have arithmetic progression and geometric progression, time and distance. Okay, so let's go to ratios, variations, and proportions. Ratios, variations, and proportions. Once the concepts of ratios and proportions, there are different compositions, okay, different types of ratios and all that we will be studying in this class. Different pattern of variations among variables. Yeah, variations happen, okay, but how is it varying? Based on that also, sometimes it is like continuous, sometimes there is some kind of relation which will relate to the different composition. Different patterns of variations among variables, then application areas of ratios, proportions, and variations in real life situations. This is the three things which you will be covering in ratios and proportions. So let's go into, so when I come to the concepts of time value, the other sessions, I'll be telling you about their objective. Okay, now firstly we will be covering today ratios, proportions, and variations. Okay, so now let's say this is the first, to understand, assuming that you guys are beginners, so I'm telling you about ratios. Where does this ratio concept come? So normally when you are having a food. Okay, the basic need of the humans is to have food. In that you may have like water and food, the hard content of the solid food. So how much proportion of water you should drink when you take some proportion of food? Okay, scientifically there might be many ways. Okay, so once you have a solid food, you may say like I will take around 500 grams of food. Then how much amount of water should I have? What is the liters? That is in liters. Here the food is in grams, let's say. But no one will say like, oh, for 500 you should have this much of water, but they need to know what is the ratio. Suppose I take one quantity of something, I can have 3 quantity of it. Now the water is in liters and the food is in grams. Now how much grams of water, how much grams of food I should eat for this much of water, let's say. So that quantity we will not say, but we will tell the ratio. That is 1:3. Let's say example 1:3. Now that is in liters, but this is in grams. How will I find out? So to understand that, you will be learning the basics of ratios, and not only for two quantities, there can be 3, 4, 5 quantities which are interrelated, and I want to find the ratio of each of the item to reach some goal. Okay, so ratios we will usually present with the symbol called colon. Okay, the colon symbol we use for the ratios. Here you have A and B, so ratio of A and B you are representing here. Okay, now in this material, okay, you can see ratio is a comparative relationship between two quantities of same kind expressed in same units. Okay, now I gave you an example that it is in liters and it is in grams. Okay, so these two are different units, am I right? So it is, but you have to convert it into the grams. That is a real-time example I gave you, so you need to convert it into grams, or you can have ratio like some suppose you have water for 1 liter, right? You can convert it into other that is in different. Okay, I gave you an example like water, the ratio. I can say that two are in different units, but to make it in one unit, I can say with respect to ratios. Later with that, you can practically arrange how much of water and how much of solid food you can have. Okay, let's go to the ratios. Concepts relation between two quantities, same kind, expressed in same units. Okay, when you have the quantities in different units, you use ratio in the same unit. You will not tell 1 liter of water is to 500 grams of, no, you will not tell like that. You will have a common platform or a unit method. You will say whatever is the unit of the water and whatever is the unit of solid, you need to have some ratio between them. That to make it common, you use the ratio. Clear? In a class, first there is this example. Okay. Okay, in a class test, A secured 80 marks and B secured 40 marks out of 100. Then we compare A secures double of B. Okay, 80 marks is by A and 40 marks by B out of 100. How am I telling it double that of B? Okay, now you will see 80 is to 40. Okay, now how did I get 2? So you can do the normal division method. 80 by this can be written as this also. This is also another way of writing. So 2 times if you take, okay, 4 ones are 4 twos are, so it is 2. So the ratio is like A is 2 times more than B. Okay, so A by B is equal to 2. That is why they say it is double. This is 80 by 40 is 2 is a pure natural number and no unit is associated with it. Okay, so you can take it directly. I gave you example of water and food that has a unit, right? So we can't take it, but we have to tell a ratio. That ratio will be used to find the quantities. Okay, I hope you understood the point. In ratio is to B, A and B, so we have some names for that. The first one we called it as antecedent, and the second one we call it as consequent. Okay, so A is to B, we have antecedent start with A and consequent. Why these terms are necessary in MCQ? They'll say, they may ask you, right? Assume that antecedent of the ratio is this one A, or they say some number, and consequent as some number, but you should know which is it, right? Whether it is the second part or the first part. Suppose the antecedent, let's say they will say you have antecedent of 40 and and suppose consequent as 80. Okay, now what you say, the ratio is 1/2. Okay, it is different. So 1/2 and 2 is little different. That is like A is half of B. Got it? So that is important for you to know an antecedent and consequent. Next we'll go to the properties of ratio. The value here we have two properties, okay, where the value of the ratio remains unchanged when the terms of the ratio is multiplied or divided by the same number. So I have multiplied or divided by the same number, still the ratio remains unchanged. How do I say that? Now I have 2:4. With the same property, I can say the multiplied or divided 1:2. Then the other one is 4:8. All these things are, let's say this is the basic one, I multiplied, finally I'll get multiplied by 2, and this is multiplied by 4. Okay, well, finally whatever ratio you have at the end, you will get 1:2. Okay, another one, let's say 10:2 I have. Okay, so and I have one more ratio called 5:1. Is this 2 same? Yes, 2 ones are 2 5s are. Okay, that is what they said. If I multiply or divide by the same number, the value of the ratio remains unchanged. The other way is like, what is the ratio of okay, now there is another way, ratios, like for example, I'll ask you 10:2, okay, and 20:10, and then I give 5:2, 1:5, okay, and I give 2:1 and 1:5. Okay, these are some of the ratios you have. Now I want to know which are the same ratios. Okay, so usually what we do, the shortest way is find all the minimum ratios. Okay, can I divide this here? How much is there? 10/2 is 5. Here how much? 20/10, so it is 2. Here 5/2, it's a 5/2 only. Here 1/5. Here 2/1 is 2. Here 5. In this I can say this and this are having same ratio because the results are same. Now this and this are same because now these two are completely different. Get it? So this is what they mean. The value of ratio remains unchanged when the terms of the ratios are multiplied or divided by the same number. Okay, now 2:4 is multiplied by 2 and you get 4:8. Okay, then still their ratio 4:8 ratio is 1/2. Then divided by 9 is 1:3. If I divide 1/3, okay, that is what they meant. Now the second thing is, two or more ratios can be compared by reducing them to the same denominator. If suppose I want to compare, let's say 1/2 is to 5 by 3. How will I say? And one more ratio is 1:2. So this is hard to compare. So if you want to compare such times, you make the denominators same, reducing them to same. This is the normal like of fractions. Ratios you can relate to the fractions with respect to division. Okay. Now in the ratio 3:4, 8:12, which is greater they are asking. Same like in this 2, I want to compare this. Comparison means either is it equal, lesser, greater, not equal, whatever. Okay, so in that case I want to know what is the comparison between the two ratios. Okay, now let's come to the comparison. Here we have 3:4, 8:12. Okay, so how will I change it? Now multiply here. This is what we call the second one, denominator. You can say this both can be written by 3/4 and 8/12, right? How will I compare? The best way is you just make it as 12. 4, how will I make it 12? By multiplying with 3. If I am multiplying 3, I should also divide by 3. Why? So that 3/4, if I change with some other number, okay, it should still result 3/4. Okay, now I am taking 3/4 into 3/3, still it remains same. So here it becomes 9/12 compared with 8/12. Okay, so this is the what we get. Now with this, how will I know 9/12 or 8/12 which is greater? This you need not worry, it is same. So you take the numerator and you say that is greater. So 9 is greater, we conclude. So 9 and 12 came from 3/4, right? Is greater than 8/12. Clear? So this is how you will find the ratios. Comparison. This is how you will do the comparison of the ratios. Now let me give another example. Now suppose you have 2/3, okay, and I want to, okay, the general one, simple one, you guys have 1/4. What is this? It's a quarter. Okay, we call it a 25%. And one more I have 3/4. Okay, in this, which one is bigger? Just 75% is greater than 25%. So this having the denominator same. Now if I have 3/4 and half, okay, and I will ask you like, not this, okay, 3/4 and 1/2. Okay, so in this we know in real life that 3/4 is 3/4 of the full, and this is half. This is obviously bigger, but in other way you need to convert it into normal denominators every time. Make sure the denominator is same. So 3/4 and 2/4. Now you will say this is greater than this. Clear? Next we have this is done with the properties. So finally, what did you understand from the properties? We found that when you multiply or divide with anything, still the ratio remains same. Everywhere the ratio remains same. Then if two or more ratios to be compared, you have to multiply with the to make the denominator common, and then you can compare. Okay, this is what we covered now. Next we go to the ratios of equality and inequality. Here, when do you say it is equal? When both A and B, that is antecedent A and B, let's say this is one of the ratio, okay, A1 B1, another ratio A2 B2. Okay, now if they have this A1 is equal to B1, then we call it as equal ratios. Means suppose I want to make a dosa batter, okay, I want to put equal proportions. Then I say that means equal proportion means whatever for dosa, what you do, you have a urud dal and you have the rice, both of them I want equal proportion. So if it is equal proportion means if I put 2 glasses of rice, I have to put 2 glasses of urud dal. That is what they mean equal ratios. Then if A and B, then the ratio is called, if A is greater than B, then we call it greater ratio. Then I say that when you make a dosa, you should put rice of more ratio. Okay, whatever, if you put urad dal more, it will be a different dish. So the proportion is like greater inequality. They are not equal, so they are inequality. That is, A should be greater always than B. Next we say the lesser inequality is like rice should be lesser than urad dal. So A should be always lesser than urad dal. If it's so, some other dish will be happening, will be cooked. Okay, next, this is what you have understood. Let's give some example now, as I spoke about ratios and all. Now let's say we have here 2:3, just as a brush up, 3:4, 1:2, 2:2, 4:4. Okay, now in this, what are the concepts we studied? First, ratios remains same whether you multiply or divide. Okay, let's see how much is the ratio. 2/3. What is the ratio? 3/4. What is the ratio? 1/2. What is the ratio? 1. What is the ratio? 1. Okay, this 2 is following that method. Second, what did we ask? Second, we saw that here, compare. How will you compare? So if I want to compare, which are the things? Let's say A, B, C, D, E. Now I want to compare A and B. Can I compare A and B? 2/3 and 3/4. What is the relation? We can't find here. So what I do? I want to make it common. So what I'll do, this one I'll multiply by 3 divided by 3. Here I will multiply by 4 divided by 4. Why did I multiply by 4? Because I want the denominator to be common. Okay, now 8/12 and 9/12. Now I will say 9/12 is greater than 8/12. So basically this B is greater than A. Okay, that is all. So we similarly you can do for others. Next we saw the equality and inequality ratios. Okay, now here one of the concept, this is equal ratio. Okay, and this one is lesser than 2. It's a lesser inequality. And where is the greater inequality? There are no examples I have given which is having greater inequality. If I want, I can say 5:3. This can be greater inequality. Clear? So with these examples, almost all the properties and all this are covered. Okay, now next we will go to inverse ratios or reciprocal ratio. So if once I told you 2:4 and 4:2 are not same. Okay, because the ratio is 1/2 here the ratio is 2. Now this concept is why? By common sense we usually say, oh, this is just opposite of it, inverse ratio, right? So that is what we call it as A:B becomes B:A. We call inverse ratio. Okay, so that is the concept here. We call it as inverse ratio. Next we have different kinds of ratios. Okay, now till here you saw the basics of it. Now different kinds of ratios. We have compound ratio, duplicate ratio. Okay, now they might have given different types of ratios and all, and they may ask find the compound ratios of this, given some terms or some ABCD values they may give, and they'll ask you how to find the compound. So when you are finding compound, now let's say A:B you have done, then D:E, then F:A, some value, okay, random value. So we have no idea with this, sorry, G. Okay, there's no idea. So I want to find the compound ratio for this. Compound ratio means you will tell these ratios multiplied. ADF BEG. Okay, so here comes for the ratios A is to B, C is to D, E I have just changed. So multiplication of this will become B, will be the compound ratio. Clear? And the compound ratio of two reciprocals. What is reciprocal? I said 1 by 2 and 2 is there, right? That is 2 is to 4 and 4 is to 2 you have. So when you do compound interest for this, how much it will be? This and this I should multiply. It is 8 is to 8. So it will become 1. This is one of the property. In case they ask what kind of questions may come. So they may say A, D, F we have. Okay, I have given, and B, E, G is given. And they say that it is having a compound interests of compound interest of 1. Okay, so when they compound ratio of 1, if they say I have compound ratio of 1, then you can think that this both will be same value. And if they have given A as 2, B as 1, okay, I'll just clean it up once again, I'll explain. Now suppose you have A, B, C, okay, D, E, F. Okay, now inverse ratio I said A by B and B by A. Okay, this will end up into 1, right? That is if they both are inverse, they are having inverse, right? So it will become 1. Now I will give you 2 values in both of them, and E is equal to 1, F is equal to 1. Now find C and D. Can I find? So now A is 2. As I said, its compound ratio should be equal to 1. Means they both should become same. 2 into 2 I did. Okay, and I don't know C. Then ratio is E and F, 1 into 1. And I don't know he. Whatever is the value here, it should be 4C colon 1D. Account of component should be same. So what can I do? The C can be what? 1 by 4 or 1. D can be, if it is 1 by 4, then it should be 1 or 4. Okay, these are the possible values. Okay, so if C is 1 by 4, then D is 1. If C is 1, then D is 4. Okay, that is a possible. So this is why you need to know. They may appear simple concepts, but this concept, if they say compound ratio, means you should understand what is the meaning behind that. So that is why we have this. AB is a reciprocal ratio of B by A. So this is reciprocal ratio, that just changing the positions. Antecedent and consequent get exchanged, and if it is exchanged and you try to find the compound ratio, and it will be 1. Next we have duplicate ratio. Duplicate ratio, here A we have and B we have, C and D. So this all are different. If I write again A and B, they both are same, and we call it as duplicate ratios, and their compound ratios will become this. See here, duplicate ratio of this will be A square is to B square. Okay, that is not a problem. Two equal ratios are compounded means bounded together, then the resulting ratio is called duplicate ratio of the given ratio. That is A is to B is A is to B into A is to B, that is A square ratio B square. Now when we have done this for square, you can think of triplicate. So A into A into A, this dot I mean into A colon B into B into B. So this is a cube colon b cube. Clear? So this is the this kind of compounding together we call triplicate ratio. Okay, so then we have another one. Okay, that is, I have done all squares, right? I can do, if it is squares, square root of 4 is 2, 2 square is 4. Okay, now till now you did this. Now there is something called duplicate ratio and subtriplicate ratio. What they do is they find roots of is a subroot of a is to b. Okay, so when you find the square root of the given ratios, we call it as duplicate ratio and triplicate ratios. Next we go to the continued ratio. Now one more thing, in subduplicate and triplicate, how it will be useful. They may ask the question like find the subtriplicate of the given compound ratio. So 8 is to 1 if they give. I have said subtriplicate. Okay, subtriplicate means I have to find the cube root, right? So cube root is 2 is to 1. Okay, they may use this technical concept based terms to describe the question, so you need to know all these things. Okay, now continued ratio, when I go, is a relationship between the magnitudes of 2 or more ratios and is denoted by a is to b is to c. Okay, now I will show you continued 2 or more ratios and is denoted by a is to b. Now I have two ratios, a and b. Okay, and one more is there, c. Okay, these three together, if I want to relate, we call it as continued ratio. The continued ratio of, now let's say we have 2 is to 3, 4 is to 10. Okay, this is normal ratios. What is the ratio between them? 2 by 3. 4 is to 10, what is the ratio? 2 by 5. Okay, now how will I find the continued ratio? Here, to get continued ratio, you write like this. Okay, 4 is to 10 you have. So simply multiply this. 8 is to 30. Am I right? But this one will become the multiplication of this 2, that is 12. So the answer is 8 is to 12 is to 30. And they have said 4, 6, 15, right? So 2 4s are 2 6 are 2 15. Other ratio is 2 is to 3 is to, no, it is not possible. If you want to divide, you have to divide with one common number. Clear? Let me ask another question. Okay, 10 is to 2 and I have 2 is to 3. Okay, no, I don't want to give the same number. Let's take it as 4 is to 3. Okay, now I want to find the continued ratio. Now 10 is to 2, 4 is to 3 is 40 is to 6 and 8. Okay, this one you can divide by which number? 2. So 10 is to, no, 20 is to 4 is to 3. So this will be the continued ratio for these two numbers. Okay, next. So this is done. Now we will go to the points to remember, few of the points to remember. That is, first bring the quantities. Okay, where you are trying to make, as I gave you the one example, liter of water and 1 sub grams of food. If it is there, first change it into same units and then try to find the ratio. Okay, if A is equal to 2 and B is equal to 50, A is 200, like rupees, I want to convert it to paise. So 1 rupee is 100 paisa. So 2 rupees is how many paisa? 200 paisa. That is what they meant. Okay, so they converted it to same units and then put 50, and then you divide it with let's say 50, 0 0 you remove, 5 times 5 ones are 5 fours are, so 4:1. Okay, division is more important. This is done. Next we have when the quantity is increased by given ratio, multiply the quantity by greater ratio. Okay, when the quantity is increased by the given ratio, multiply the quantity by greater ratio. It means when you have some value here 2, it's increased with the given ratio, means you have to increase 2 times, just multiply by 2. If it should be decreased 3 times, divide by 3. That is what they mean. Okay, so increase and decrease here means increase is multiplication, decrease is division. Plus and minus, no, it is multiplication and division. When both are increase and decrease, whichever quantity with let's say it is doubled, then multiply it. It is increased by 2 times, so multiply. At the same time, some quantity is decreased by 3 times, then divide by. So both multiply the result by lesser ratio to obtain the final result. So these are some hint points to remember. It doesn't come under some concept or something, but you need to know. Next we have proportions. So with this we finish the ratio. Next we'll go to the proportions. See, proportions and ratios are not much difference. Okay, there we say the ratios have to be in same quantity, but still we can convert it into proportions and then change. Okay, if 2 ratios are equal, then we say that 2 ratios are in proportion. Okay, in case that ratio what you get, that is the proportion. 2 ratios are equal, then we say that 2 ratios are in proportion. Now 1:3 I have taken. Okay, now that is the ratio of 2 quantities. One of A, let's take the example of dosa batter. 1 quantity of rice, I need to put 2 quantities of let's say urda, 1:2. Let's 3, 1:3. Okay, if it should be a soft one, we will use 1:3. Now what happens here? I have one more 2 glasses of rice and 1 glass 3, right? So 2:6. Let's take this example. 1:3 I want, and I want to give another ratio is 2:6. Okay, now I have taken let's say to make rice. Okay, let's say to make a rice, I want cook rice. You want to put rice, and this is water. Here I want rice, let's say rice, and I want urud dal. Okay, now this 2 is 1/3, 1/3. We call this as proportions. The proportions of this and this is same. Whether you are cooking dosa or the cooking rice, your proportions are same. That is what they meant. If 2 ratios are equal, 2 ratios, that is this 2 ratios are equal, then we say 2 ratios are in proportion. In other words, 4 quantities A, B, C and D are said to be in proportion if A:B is equal to C:D. So here A, this is B, C and D. These are in proportion if A:B is equal to C:D. Got it? Or this can be written as A/B is equal to C/D. So that is the concept. Now let's come to the properties. In this, 4 quantities are in proportion if A by or. So this much you have done, and one more is AD is equal to BC. See, you have multiplied, you have done ratio, you have done division. If it is multiplication, it will be AD is equal to CB. This is like cross multiplication. Okay. Next, continued proportion. We'll go to continued proportion. Continued proportion, what happens, A is to B you have, there is another, say let's say C is to D. These two ratios will become continuous proportion if that in between terms are same. Now B and C, if B and C becomes equal, then A is to B, B is to D. This is a continuous proportion. Okay, now if three quantities A, B and C are such that A is to B and B is to C, then we say that three quantities are in continued proportion. If three quantities are in then there is some condition here. Okay, let me go back to the previous concept. What I said, A is to B is equal to C is to D. Okay, then A by B is equal to C by D. Okay, they are equal proportions. And also AD is equal to CB. This is what I said. Now what happens in continuous proportion? I say this and this becomes equal. A is to B is equals to B equals to D. Okay, these are in continuous proportion. Now the same concept when I use A by B is equal to B by D, then this will become AD is equal to B square. Okay, so this is what the change happens when you are in continuous proportion. AD becomes CB, but here it becomes B square. Okay, so that is what we get, then B square equals to C. Now let's say 3 is 6 and 12 are in continuous proportion. When they say, it means 3 is to 6 is equal to 6 is to 12. That is what they mean. So find out are in continuous. So what is it? How much? What is, or the question can come like this. I'll write here. 3 is to, they have given 3, 6, 12. Okay, 3, 6, 12 are in continuous proportion. Or the question may say like 3, A, 12 are in continuous proportion. Okay, now and the compound of A, B, C is equal to, let's say some, I want to change 6, 1, 36. Okay, so let's say they say assume A is equal to 3, B is equal to 6. Okay, I'll reframe the question. Let's say A is equal to 3, B is equal to 1, C is equal to 12. This is the question they have given. And they say that B is unknown. Sorry, A is 3, B we don't know. Okay, C is equal to 12, assume. Okay, so and they have given that A, B, C together should be 36. Okay, now try to find B. And also they say condition, they are in continuous proportion. When say it is in continuous proportion, it means you can use this formula, B square is equal to AC. Now B square we have no idea. Okay, here AC, not sorry, here AC, it is not ABC, it is AC. They have given 36. Now B will become 6. 6 6 are 36, right? So here I can have B, square root of B is 6. Now what is the final answer? 3 is to 6 is 6 is to 12 will be the answer. Okay, that is what they mean here. And another example are oh sorry, and one more thing, B square is plus or minus, am I right? So which one you have to take? You can take any one of it. Okay, here is another example, 2 minus 4 8. That means 2 is to minus 4 is equal to minus 4 is to 8. Okay, now are in continued proportion. So what is the value? The whole square is equal to A and C is 16. Okay, so you get 4 square is equal to 16. Okay, so you can either give plus or minus in such case. Next we have mean proportional, third proportional and fourth proportional. Okay, now let's see what is all these things. In mean proportional, what happens, given three proportions, that x, y, z are in continued proportion, then y is called mean proportion. That is the middle one in continuous proportion, this one. So as I gave you 2 is to there was some like 3 and 4 and 12, right? So this middle one we call it as mean proportion or geometric mean of x and y. Okay, let's see how is it. Okay, now I have